structural equation modeling, SEM, or you can say a structural equation, is a type of statistical multivariate data analysis technique that analyze the structural relationship between variables. SEM evaluates a dependent and independent variable. It is basically a hybrid of metric analysis and structure modeling. So this is versatile and extensive data analysis network, where in addition, latent variable metrics and model measurements verifications are obtained. SEM is a hybrid of metric analysis and structural modeling for multivariate data analysis. This takes into account measurement errors and factors observed. The factors are evaluated using multivariate analytic techniques. This is an important component of the SEM model. Methods of SEM. Two popular methods dominant SEM in practice: covariance-based SEM, that is CB or SEM, and partial least squares SEM, PLS SEM, also called as PLS path modeling. Now, CB SEM is primarily used to confirm or reject theories and their underlying hypotheses. This approach confirms or rejects hypotheses by determining how closely a proposed theoretical model can reproduce the covariance matrix for an observed sample dataset. PLS SEM is evolving rapidly as a statistical modeling technique. Over the last few decades, there have been numerous introductory articles on this methodology that you can refer to understand this particular method in deeply. Next is classification of SEM. Structural modeling falls into four broad categories. These structural equation models are path analysis, confirmatory factor analysis, latent variable structure model, and latent growth curve model. We'll understand each one of it deeply. So when I say path analysis, the name itself says there could be a structural equation model. In use is the application of structural equation modeling without latent variables. So the best part about path analysis is that it includes the relationship among variables that serve as predictors in one single model. The classic example of this may be mediation model. Path analysis, another structural equation model type, is an extension of the regression model. In a path analysis model, from the correlation matrix, two or more causal models are compared. The path of the model is shown by a square and an arrow, which shows the causation. The regression weight is predicted by the model. Confirmatory factor analysis. Confirmatory factor analysis, also known as CFA, is a way ahead of data reduction. CFA is also known within SEM as the measurement model because it's the step taken to determine how the factors are measured by the indicators. The confirmatory factor model is SEM treats intelligence as a latent variable which can be measured on the basis of test scores. These are spread out in four areas: reading, writing, math, and analysis. So the structural equation modeling example basically shows how to estimate a confirmatory factor model. The primary benefit of structural modeling is that it is entirely free. It requires an installation only. Next is latent variable structure model. So for these models, there are specific diagrams which I can share later with you all. The next structural equation model for analysis is the latent variable structure model. Very next step is to fit the structural model, which is what you probably think of when you hear about SEM. It is mainly using the measured latent variables within the path analysis framework. Once you have declared the latent variables, you can hypothesize and test their relationship. Fourth is latent growth curve model. Another popular use of structural equation modeling is longitudinal model, commonly referred to as growth curve models. Let's say, for instance, you have multiple observations of the same variable over time. You may declare and intercept a slope for the subject's papers over time as latent variable by constraining the path coefficients in a specific way. Since the paths are constrained, we have to estimate on growth curve modeling that means of the latent variable. These means give us the overall intercept and overall slope across all the subjects. So latent growth curve models are related to and offer an alternative means of running mixed model and longitudinal model or a data. These mixed models are often known as individual growth curve models. Now, careers in structural equation modeling. So you might be basically a mathematics graduate or simple bachelor computer application. Students with a master's degree in economics or social science can also aspire to have a career in equation modeling. You may take up data science or data analytic course to prepare yourself for structural equation modeling research analyst role you have been dreaming of.